Today, we are going to reimagine Legend. We are going to make a modernized version of the PlayStation 1. We're gonna give it a huge graphical upgrade, we're gonna slim it down with a new design, and we're also almost going to start several small fires along the way. Oh, crap. This console right here changed everything, and it was almost called the Nintendo PlayStation. That's because once you peel back all the layers of electronics, you will find that this machine is powered almost entirely by spike. You see, in the 90s, Sony really wanted to get into the rapidly growing home console market, so they decided to partner with Nintendo to create a CD-ROM add-on for the SNES. But Nintendo, despite all of their cutesy games, well, they don't always play nice. So after some disagreements about licensing and royalties, they went behind Sony's back and struck another deal with Philips. Sony then saw this and said, all right, well, we don't need you guys, we can just build our own game console.
With blackjack and hookers!
And the rest is history. In 1994, this system changed video games. With full 3D graphics, CD quality audio, and full motion videos, the PlayStation represented a quantum leap for gamers. But 30 years on, things have continued to progress, and these days, there is quite a bit you can do to update these old consoles. So what do you say we tear into it and get started on this project? No doubt some of you guys probably noticed that the color of my PlayStation is looking a little bit off. And I actually thought that maybe at some point somebody had spray painted this thing, but tearing the system open reveals that no, in fact, this is just really bad oxidation. Not to worry though, because part of this project is going to be slimming down the PS1, and that means we are going to be building an entirely new shell for it. There's also another problem with this system, one that would normally destine an old console like this for the local landfill. I got this system on the cheap because its CD-ROM drive is completely cooked. But by the time we're done, the lack of a CD-ROM drive is going to be a complete non-issue. So let's just put it where it belongs. Working my way deeper into the PlayStation, I was pleasantly surprised at just how easy it was to tear everything down. But of course, all good things must come to an end, and pretty quickly I hit our first major roadblock. A lot of the chips we're going to need to access for some of our mods are hidden under this RF shielding, and as it turns out, it's soldered right to the motherboard. Removing it involved heating up these mounting tabs and then using a copper wick to suck up all the solder. The same technique can often be used for fixing your mistakes when you're soldering because liquid solder loves copper and will be drawn right into it. This last tab holding the cover in place was particularly tricky to access, and I couldn't even get the wick in there, but eventually I heated it up to the point where I could just wiggle it free. There we go. Now, as I clean up the mess from the last step, let me direct your attention to these very important markings on the motherboard. This is a PU18 motherboard. And that's no accident. I made sure I got this specific version. There are dozens of different PlayStation 1s, so if you plan on modding one, it's important to make sure that the version you have is compatible with the mods that you want to do. And don't worry, there's actually a much easier way to check which revision you have. Just look for this sticker on the underside of the console that shows the model number. And speaking of checking the bottom, when I flipped the motherboard to continue my cleaning, I immediately noticed something that I missed before. Turns out the previous owner of this console was something of a deviant, because this is an old mod chip which allows you to unregion lock your PS1 and play burned games. Now, I shouldn't judge too harshly because we are going to do something very similar, but what I can judge is this soldering job. Many of these wires had already broken off, so let's just remove it entirely, because I've got a much more modern solution planned. So, spoiler alert, but today's video is sponsored by Bamboo Lab, and that means that we are going to be 3D printing an entirely new case for our PlayStation. And in order to do that, we are going to use my favorite 3D printer of all time, the X1 Carbon. Now, we're really gonna flex this machine's muscle and show off some of its cool new features, but first, I just have to gush for a second, because this is the printer that got me into 3D printing and convinced me that 3D printers are tools and not just a fun hobby. Bamboo has created an ecosystem that is so easy to use and intuitive that the printing process kind of just becomes an afterthought. That means that I'm free to worry about design and engineering instead of bed leveling and volumetric flow rates. I just click print and I know it's gonna come out great. Now, I've also got a bunch of their fun new filaments that we're also gonna play with, but I'm getting ahead of myself because we still have to do all of the design work. So the first thing I'm going to do is create a detailed model of the motherboard, which is going to pay huge dividends later in the project. I started by busting out my trusty digital calipers and measuring not just the PCB, but also all of the components that are mounted to it. By creating a digital reference like this, I can really speed up the design process. Not only will I know where all the ports and mounting points are for a new case, but once we install some of our other mods, then we'll be able to orient those in a digital space and create the tightest possible package. Because I think with this first mod, we should be able to slim down the PlayStation quite a bit. Oh man, so this is very exciting. This just arrived in the mail, and what this is an X-Station, or more broadly, an optical drive emulator. Now, I'm sure many of you are hearing the word emulator and getting a little concerned, but what this allows you to do is to plug an SD card directly into the same data lines that the CD-ROM drive used to connect to. Now, there's a whole host of benefits here, but principally, this is a replacement for a CD-ROM drive, and also that mod chip that we removed earlier. There are some other side benefits too that we will discuss, but first, I think we should start installing this thing. Installing an X-Station, unfortunately, is not for the faint of heart. The first thing we'll be doing is severing some of the connections to this controller chip for the CD-ROM drive. I heated up the contact pads on the motherboard and then used a pin and a set of tweezers to slowly lift up some of the legs on the chip. This is a delicate operation, and I did unfortunately end up lifting one of the pads while doing it, but hopefully that won't matter because, well, we're trying to sever that line anyways. On the opposite side of the board, I had to scratch away at the solder mask and prep two of the vias to be soldered to. I then lowered the X-Station's quick solder board in place and started connecting it. This specially designed PCB perfectly lines up with a bunch of contacts on the motherboard. By adding a little dot of solder at each one, you can tap the X-Station directly into the data lines that are used for transporting information from the CD-ROM drive. Once it's set up, this will allow us to have hundreds of games installed internally on the console, play games regardless of their original region, and it will occupy way less space than the original CD-ROM drive. After removing this resistor and connecting one last single wire, we should be good to go and ready to use our X-Station. Oh man, so that was definitely not the easiest soldering I've ever done. Also probably not the hardest, but while I still have all of this soldering stuff out, I actually want to install two more mods on the PlayStation. This next one is a reset mod. And the reset mod works hand in hand with the X-Station. You see, these old consoles came out long before anybody had a concept of a home screen, but as you'll see later, with an X-Station, you do kind of get one. Unfortunately though, there's a problem. There's no way to access that screen once the system is already running. So if you want to switch games mid-session, you have to stand up, walk over to your PlayStation, and then reset it, which is kind of annoying. So this mod fixes that. It simply taps into the controller inputs, and when you press the right combination of buttons, it'll send a signal to reset the system and take you back to your new home screen. So with that done, the next thing I want to do is give this system a complete graphical overhaul. This is the RetroGem. And the big headline feature of it is that it adds an HDMI port to your PlayStation. But it also does a heck of a lot more than that. At this point, all of the TVs in my house don't have RCA or S-Video inputs anymore. So if I want to connect the PlayStation, I have to use one of these analog to digital converters. And the results are subpar to say the least. The picture looks awful, and talk about a mess of wires. So by installing the RetroGem, we can use a single, simple HDMI cable. And yeah, I know, I'm sure somebody's gonna say, but Zach, there are cheap aftermarket HDMI cables that you can get for your PS1. And well, you're right, the RetroGem is a vastly superior product, and I'll tell you why as we install it, and we'll also talk about some of the other cool bonus features too. If you thought the first few mods we installed looked a bit tricky, well, buckle up because the RetroGem is no walk in the park, but it is gonna be worth it. First, we'll start with the easy stuff, like removing the serial output port. You could do this with hot air, but honestly, I found it pretty easy to do with a solder wick. Then you'll need to tinker with the power delivery system of the PlayStation. We'll replace these old capacitors with more modern electrolytic ones, and we'll also remove this teeny tiny guy down here. Then the real fun begins, and we can start installing the flex cables. In order for the RetroGem to be able to respond to controller inputs, much like the reset mod, we'll attach this flex to the connector where the controller ports plug in. Now we will tinker with these data lines even more later, but for now, let's stick with the RetroGem. Sound is a big part of your gaming experience, so next we'll will need to capture the audio signal from the audio processor. This flex grabs it before it gets converted to analog. And that's kind of the beauty of the RetroGem. It captures both the audio and video signals while they're still digital, ensuring a perfect lossless conversion. And speaking of video, that's the next step. This last flex cable captures the raw video output. And with it, the RetroGem can perform all sorts of visual enhancements at an extremely high level. We're talking upscaling, HDR effects, smoothing, and so much more. And that is what sets this system apart from a simple HDMI converter cable. It handles everything at a digital level. Those cheap cables only have access to the analog signal that used to go out over the RCA ports. So you're essentially going from digital to analog and then back to digital, which introduces a ton of artifacts, noise, and unwanted processing. So as you'll see later when we do some testing, the RetroGem provides a huge visual upgrade. But first, remember how I said we'd be tinkering even more with the controller data lines? Well, let's talk about that. The next thing I want to do is modernize the inputs of our PlayStation. I have taken wireless controllers completely for granted, and I don't think that I could go back to being tethered in place by a wire. Now, in past projects, I've shown you how you can use these wireless adapters to use newer style controllers with older retro game consoles, but then you have these big, ugly dongles sticking out of the front of your system. So I did a bit of research, and I think I've actually found a much better option. This is an ESP32, and you can kind of think of it like a very simple open source computer with Bluetooth. With the right software, this board allows dozens of different retro game consoles to interface directly with new modern wireless controllers. So the first thing I had to do was connect it to my computer and download that software, which is called Blue Retro. Getting it set up was not the most user-friendly experience, but there are several guides available online. It took me a couple of tries, but I did eventually get it working. Then I had to find a way to connect it to my controller ports, and this was a little bit complicated. I started by peeling back this protective shielding and exposing the PCB that handles inputs and outputs. What we need to do is tap into these traces right here in the center. And here's the neat thing about these ESP32 boards. They have a bunch of conveniently placed data input terminals. So all I had to do was follow this diagram and connect the wires from the PCB to specific pins on the ESP. And essentially what this does is translate all the PlayStation's inputs and outputs to Bluetooth. And that in turn means that theoretically, any Bluetooth controller should now work with my PS1. And likewise, I should be able to add a similar setup to just about any retro game console. So if this works, it's going to open up a whole lot of possibilities. But I'm getting ahead of myself because we still haven't even tested it yet. In fact, we haven't tested any of this stuff. So I set up over on my desk to do just that. And it's probably worth noting that this is not the way to do things. A proper procedure would be to install one mod at a time and test each one individually. That way you can avoid any confounding variables. But I should probably go buy a lottery ticket because watch this. Okay, here we go. I'm so nervous. Okay, HDMI 3 popped up. Oh man, come on, come on. Oh, it worked on the first try. Yes. Oh, gotta check the controller still. Let's see. Okay, controller. This is pulsing, which means it's in pairing mode. I got a rumble in the controller. Oh, look, wireless controller works. Ladies and gentlemen, we are in business. Oh man, I am so pumped that that actually works well. So that isn't it for the mods that I want to do, but it is most of the hard stuff out of the way. And at this point, we are almost ready to start prototyping our new case. But there's two things that I want to do first. I have to update our 3D model to include all these new mods, because not only are they going to affect the final shape of our PlayStation, but we're probably also going to need to design some mounting brackets and stuff like that. And then second, well, I actually want to do one more mod that's going to have a huge impact on our final design. A big part of this project is that I want to slim down the PlayStation as much as I possibly can. And if you're looking for some fat to trim, a good place to start is the PSU. This thing uses some old antiquated technology and is much bigger than it needs to be today. So I went online and I found this, an REPSX. And a big part of the way this thing slims itself down is by outsourcing the conversion of AC to DC power to an external adapter. You plug a 12-volt power supply into this plug right here, and then that subdivides into the various voltages that the PlayStation needs. But the thing is, I don't have a lot of 12-volt adapters kicking around the house. So I think to make this thing even more convenient to use, I'd actually like to convert it to be USB-C. And doing that is actually a lot easier than you might think. It all starts with one of these USB power delivery trigger boards. By setting these dip switches, we can configure it to request 12 volts of power from any standard power delivery adapter. I'll link the one that I use down in the video description, along with all the tools and materials that I've used throughout this project as well. As far as the RE-PSX is concerned, this is identical to plugging in its standard barrel jack, but now I'm free to use the adapters that I already have, and I could even power this system off a battery bank if I wanted to. A quick test with the multimeter confirmed that everything was configured correctly, and now we can get back to designing that new case. Remember earlier how I said that modeling the motherboard and all of the mods would pay dividends later? Well, it's time to reap those benefits and start prototyping our new case. In very little time, I was able to reference the geometry of those models to create a very basic enclosure where everything would fit in the least amount of space possible. So with that done, it left only one question. I still had to pick a material for our new case. And Bamboo actually just came out with a really simple product that is going to be hugely helpful here. It's just a swatch collection of their most popular filaments. Seeing previews on the website of all the different filaments is nice, but having real world references is so much better. I ended up picking this gray high-speed PETG because I know it prints quickly and easily, and it's also a great match for the original PlayStation's color. So while I waited for the bottom half of the case to print, I actually headed to the shop to do a little bit of demolition. This hunk of gray steel is part of the PlayStation's internal RF shielding and also provides a bunch of mounting points for stuff like the CD-ROM drive. Unfortunately, as it is, it stands in the way of making this PlayStation as thin as possible. So I marked out all the problem areas and then fired up my angle grinder. I am very much committed to making this system as small as possible, and this was just the first of many little side quests that I'm going to have to do in order to slim down this console. After smoothing out all the sharp edges, I gave it a couple of coats of gold paint to prevent corrosion and to match the RF shielding on my PS2. Even though no one will ever really see it, I still think it looks pretty good. Back at home, the lower half of the case had finished printing, and I was eager to do my first test fit. And yeah, everything actually fit quite well. There were a few small adjustments I'd have to make here and there, and this is far from the final design, but overall I was more than satisfied and ready to move on to designing the next major piece of the puzzle. In order to organize the insides of the PlayStation, I want to make what I'll refer to as a mid-frame. The mid-frame will hold all of our mods and also insulate them from shorting out against the RF shielding that they'll be sitting on top of. Now, the mid-frame is actually a deceptively complex part, so in order to print it, we're going to have to add a new filament into the mix. This is Bamboo's Support G interface, and it's going to make it really easy to remove all the supports from the floating and cantilevered parts of this print. I'll show you just how well it works in a second, but first, we need to address a rather embarrassing mistake that I made earlier. My X-Station isn't actually booting. I tried formatting the SD card, updating the firmware, but I still can't get its initial splash screen. However, it is turning on. So I was rechecking the solder points and pulling out my hair trying to figure out what the problem was when I realized that it's actually really simple. It's this switch right here. This is left over from the old case and simply lets the PlayStation know when the lid is closed so that it can boot from the CD-ROM drive. So I was trying to think of a solution for this when I found out that the good people over at Pixel Effects already thought of this and built a solution into the RetroGem. By connecting 2 points on the motherboard back to the RetroGem, we can actually control the lid's logic circuit in software. The first one is a simple point-to-point connection, but the second one, well, here we actually get a cool insight into how these PCBs work because it requires severing one of the data lines with a sharp knife. Buried just below the surface, there are thin copper traces used for transporting data. It's basically just a flat wire embedded into the wafer. So by cutting it with a knife and then soldering a wire back to the RetroGem, we can actually reroute that signal. And now our X-Station should function correctly. And would you look at that, our mid-frame is done printing. And now let me show you guys why I love support interface so much. These supports just pop right off. It is very satisfying to do. And while all the PCBs fit great, I realized that again, if I wanted to make the system as thin as I possibly could, I'd have to address a few issues. This first one trips up a lot of people when they're working on electronics projects, and it's just that wires take up way more space than you might initially think. So I set about trimming all of my controller port wires as short as was reasonably possible. This was finicky work and it took me some time to do it, but just look at all the excess wire that I was able to remove. That's a lot of saved space inside a very tight case. Similarly, I also trimmed the pins on the back side of the controller PCB and the ESP32 so that it would sit as low as possible. I'm telling you guys, every single millimeter is going to count on this project. Next, I needed to modify my REPSX yet again. Looking at it from this angle, I think it's pretty obvious to see what the problem is. That power switch is by far the tallest thing inside the PlayStation. So after doing some probing with a multimeter, I was pretty confident that I understood how the switch worked, and I set about replacing it with a simple wired switch that I can mount remotely. But when it came to wiring it up, I made a very simple mistake that almost cost me this entire project. Well guys, turns out I was a little overconfident and I nearly destroyed my PlayStation. Well, actually I kind of did. Turns out that switch is actually a double switch controlling two separate circuits. So when I wired it up like this, I actually sent way more voltage into one of the lines than it was ever intended to handle. Long story short, I thought I fried this PlayStation, but I ended up saving it by replacing a couple of internal fuses. And the only real casualty was this ESP32 board, but luckily, as you can see, I have a replacement. In the end, I found a much simpler solution, was just bridging those two circuits right there and then installing the switch a little further upstream. So I'll find a way to integrate this into the case, but first, I actually found another problem. I was saving this for later, but one of the things I want to do is upgrade the cooling on our PlayStation. So I got this 40mm Noctua fan, and I was gonna place it right about here. But just like with the power switch, it ends up being a little bit too tall. So I went in search of a replacement, and what I found was this. This is the replacement fan for an Asus laptop. And at only 8.5mm tall, it should be perfect for this application. It intakes air here and then outputs it here and here. So I think what we can do is integrate it into the top half of the shell, a little something like this, which I guess is the next thing that we have to design. And the trickiest part of the top was just finding a way to neatly integrate that fan. Here I actually took some inspiration from the original PlayStation and raised a small circular area. On the flip side, I created some mounting points as well as some ducting to help route the hot exhaust. Now, because of where this fan is, I also had to make a small cover to contain everything, and then I created a cutout for that power switch that we installed earlier. It took some figuring out, but with all of that done, I was ready to print what I was hoping would be my final prototype. And trust me, I know this case doesn't look like anything special just yet, but I'm a big fan of the saying that first you make it work and then you make it good. So with that in mind, let me show you a cool feature of the REPSX that I forgot to mention earlier. You might be wondering how I plan on powering that new fan. Well, there's actually a couple of contacts on our new PSU for exactly that purpose. I guess I'm not the first person to think about adding a fan to their PlayStation, but it's for a good reason. By keeping the electronics nice and cool, we can extend the life of this nearly 30-year-old console. So with everything hooked up, I slotted the top into position, tightened down the bottom screws, and oh man, would you look at this thing. Everything fits and it is smaller than the original PlayStation in every single dimension. You would have to work really hard in order to make this thing any thinner than it already is. So now that we know that it works, what do you say we make it look good? Back in Fusion 360, I set about rounding over a lot of the hard edges, adding some subtle design tweaks, and just generally sprucing up the case. I added some air intakes, the PlayStation logo in the lid, and I also stole a feature from the PlayStation 2. You see these rails on the top and bottom? Well, I made a stand that slots into them so that I can mount it vertically if I want to. So now that all of the design work is done, we are finally ready to print out the final version of our case. And here I want to test out 3 new features that Bamboo has recently added that make 3D printed parts look less like 3D printed parts. The first one is fuzzing. You know how 3D printed parts have those very obvious layer lines? Well, fuzzing moves the nozzle around ever so slightly while printing in order to help hide those lines. It effectively adds a very fine texture to the outside of your print, one that I'm hoping will be reminiscent of the texture on the original PlayStation. The next one is variable layer heights. Again, when you're 3D printing, you have to pick how thick you want each layer to be. And when you have things like rounded corners, if your layers are too thick, you can end up with really aggressive stair stepping. The conventional solution is to just decrease the layer thickness, but then your prints take forever. So by enabling variable layer heights, we can use thinner layers in areas of fine detail and then crank up the layer thickness in other areas where it doesn't matter as much. That way you get the best of both worlds. And then the last one is ironing, where you go back over the topmost surfaces and smooth them out. The X1 does this by adding just a little bit more filament and also literally ironing the surface with the hot tip of the extruder. So how does it look when you combine all three of these features? Well, I guess there's only one way to find out. Unfortunately, things did not turn out great, and it mostly comes down to user error on my part. So variable layer heights and also fuzzing work well separately, but when you combine them, what you end up with is a very inconsistent surface texture. And honestly, I probably should have seen this coming. Ironing, on the other hand, actually worked really well, but I found a much simpler solution was to just take the large flat sections of these models and orient them down on a smooth build plate and then print the parts that way. So yeah, I reprinted the case with my newly learned lessons, and I also switched my support interface to Bamboo's purpose-made PETG support. This stuff is slightly harder to remove, but leaves a much flatter surface. And okay, now these prints are looking a lot better. I skipped the fuzzing this time around, and I gotta say, this Rapid PETG prints so nicely at finer layer heights that it almost doesn't even matter. So it did take some tinkering, but eventually I got the case looking the way I wanted it to, and I was finally ready to put it all together and test it out. But first, I did promise you guys that we'd play with some other filaments too, right? So here is the case in a walnut brown PLA, and then I also did transparent PETG. And actually, I also printed all of the parts and accessories in the various colors too, so that they can be mixed and matched. And honestly, that's kind of one of my favorite things about 3D printing. Once you have the initial design down, you're free to then print the parts in dozens of different materials and hundreds of different colors. So to that end, I'm actually gonna make all of these files available for free over on MakerWorld, which is Bamboo's community for sharing 3D print files. And that way you guys can mix and match and make your own versions of these cases at home. So I think that's enough talk about the case. So let's talk about the hardware and do some comparisons to the original PlayStation. Getting the system set up is so much more convenient now thanks to that HDMI conversion and also the USB-C power. Pairing the wireless controller happens instantly as soon as you turn it on, and you get a nice little rumble to confirm. And then once the system boots up, you are greeted by the X-Station main screen. With a large enough SD card, I think it might just be possible to squeeze every single PS1 game onto your system. Now, obviously, I don't condone piracy, so all the games you see here are the games that I actually own. Loading times should be dramatically better too. Unfortunately, I can't test that because my CD-ROM drive never worked. But from what I understand, it should be anywhere in the neighborhood of 30 to 50% faster. And that applies across the board for all loading screens, which makes the system feel just that much snappier. And then speaking of loading and saving, I actually have a fun little bonus mod here that I haven't talked about yet. This is the Memory Card Pro, and it lets you create up to 8 virtual memory cards on a micro SD card. It's a pretty neat piece of kit for keeping all of your save files organized. Now let's talk about graphics, which I'm sure many of you are very interested to hear about. Having a clean digital signal allows the RetroGem to give you pixel perfect graphic output via HDMI. But what does that actually mean? Well, here's a comparison to a cheap HDMI converter. And as you can see, the difference is actually kind of insane. But it doesn't stop there, because the RetroGem has all sorts of other visual enhancements that it can run as well. You can upscale the image all the way to 1440p. You can choose between multiple deinterlacing algorithms, because remember, a lot of PlayStation titles are interlaced. I actually found the default motion adaptive one works really well, so I just leave it there most of the time. You can add a layer of smoothing, which helps to reduce the jaggies that the PlayStation 1 is so well known for. And to be honest, I might actually leave this setting off just for old time's sake. Then probably my favorite feature is the ability to inject HDR mapping onto SDR content. On screens that support it, you end up with a much wider range of brightnesses and a wider range of colors too. So here's what the default image looks like, and then here's what it looks like with all of my preferred settings. And also, just for fun, here's that cheap HDMI converter again. I think it's pretty clear to see that this is a huge visual upgrade. So that is it for my modern PlayStation. And while I love how it turned out, I still think I could have done it even better. I've actually compiled all of my thoughts on that subject into a separate bonus video that is currently available for channel members. Channel members also get sneak peeks of upcoming projects, early access to videos, and other fun bonus content as well. So if you're interested, check it out. And if not, I will see you guys in the next video. Peace.